So today is applications of exponentials, and here's a typical exponential. By now you should know, oh, you saying it started with 8, and oh, it's doubling every X amount of time. So, do you get, rabbits are famous for multiplying fast. They have lots of little rabbit babies. If you have a male and a female rabbit, you might have, they can actually have like 6 litters a year. So all of a sudden you might have 2 rabbits that turn into like 36 rabbits, just literally in a year. Because rabbits are like the happy meal of the great outdoors. Everything likes to eat rabbits. Hawks like to eat rabbits, and snakes would happily eat a rabbit. It has to be a really big snake, but like down in Florida kind of snake. All right, so my point is, if this is growth, and I know it is because that's bigger than 1, and this is my start value, and you should know that. Remember that the end value goes here, and this is how long it takes to double. So let's make a little tweak to this. If I go divided by 5, everybody do that. Copy this one down and put a divided by 5. Then let's think about that. We started with 8, which means at time 0, imagine I put a 0 right there, then it'd be 0 over 5, which is still 0. Anything to the 0 would be 1. Do you get how at time 0 I have 8? Do you see how that works, that's the start value? Okay, at time 1, I wouldn't get a double. I want you to think about that. If I just put a 1 here, now it's a 1 over 5. Because the over 5 is built into the problem. And if I put a 1 right here for the x, it's going to take 5 right here. If I put in a 5 right here, then I would get a double. Because then this would be 1, and then this would be 2 to the 1, which would make it double. So what that means is doubling every 5, and then I get to pick, and I'm going to give you the problem, whether it's doubling every 5 years, or is the rabbit population doubling every 5 months, or is it every 5 minutes for like bacteria? Okay, so here's the problem. Y equals 10, parentheses 2 to the x over 3. If I said this was about bacteria and that x was in minutes, doubling time is in minutes, do you get in 3 minutes it's going to double from 10 to 20? Does that make sense to you? If I put in time is 3, I put a 3 here. Do you get, now it's going to be 2 to the 1, and then 10 times 2 to the 1 is going to be 20. See, it doubles every 3 minutes. So now I should be able to just tell you a story, and you should be able to write me that. So I decide to become a sloth farmer. Did you know there's actually a thing? You can have sloths and breed them. And if you didn't know this, it's called a slothinage. So you decide to have a slothinage. You raise sloths. So we're going to start with 2 sloths, a male sloth and a female sloth, and you're going to get 2 to turn into more at a rate of doubling every 3 years. That's really slow. Reminds me of elephants. Elephants have typically only 1 baby, 1 calf. And they carry that calf, they're pregnant with that calf for like a year and a half. It's a really slow process to make more elephants because they only get 1 at a time. And it takes them like a year and a half to give birth. So anyway, these sloths are growing at a pretty slow rate. I mean, sloths are pretty slow. They're known for that. Like they barely move. They're super slow. All right, would you write me the equation for that? You should know the starting value. You should know about what to do with doubling. You should know what to do with that every 3 years. And if you get what if you're picking up what I'm laying down, you should be able to write this equation, no big deal. Would you please compare with the kid sitting next to you and see what you think? You guys are going to compare long distance here. Would you compare Diane and Jack, please?
Yeah. Yeah, that's what I said.
Tully, compare with George. To the x over 3. See, that's not that bad, is it? All right. Now, I want you to actually make a chart, XY chart, and let's put in 0. And then we get to put in whatever we want. Do you get that putting in 0 works pretty nice and you get a nice clean answer? Do you get putting in 1 does not work real nice because then I got to go 2 to the 1/3 power. I don't want to do that. So I'm not going to pick 1. What do you think I should pick? 3. And then what would be another logical thing to pick? 6. Would you please find those 3 points? And if we were to graph this, we've been teaching you how to graph them. You should know how to graph it. It shouldn't be that bad. And you should know where the asymptote line is. So take a second, find those 3 points, put them on a graph. And this is your slothenage exponential equation. So Jack, when I put in 0, I get 2. When I put, and just to clarify, the 0 goes here. Then you're doing 2 to the 0 over 3, which is really 2 to the 0, which is really 1. And then 1 times this 2 makes 2. Okay, and then just, we won't talk through these. Just tell me, Jack, when you put in 3, you got 4. And 6, you got 8. And you see how it's doubling every 3 years, which makes sense, right? Okay, cool. All right, so how could these problems get more complicated? Well, we could ask you to graph it. And here's 0, 2. Here is over 3 and up 4, and over 6 and up 8. Looks like it's curving, just like I'd kind of expect. Is there an asymptote line? Yes, right there. How come it didn't move? Because there was no number on the outside to make it move up or down. So this is at y equals 0, and that's the HA, stands for horizontal asymptote. Okay, good. Any questions about that? All right, then write me the right end limit. Limit. All this stuff is on your next test. It's like one of those tests where I don't feel like it's that hard, but there's like a million little things you have to know, like limits again. Nate, lim, f of x, and where do you think I'm going to say next? X approaches, and when we're on the right side here, x is approaching infinity, and the answer to it? Also infinity. Which of those is the y number? The first infinity or the second one we did? No. That's the x number, just look at it. X is approaching. Okay, so I know they're both infinities, but that's the y part. And the reason I said it is because they are both the same, and therefore it'd be easy to confuse them. This is the y part right here. It's like how high will it be when you get there. All right. Then I could ask for the domain and the range. Would everybody please write down the domain and range in interval notation? That means like parentheses and brackets and that kind of stuff. I'll be there in just a second. All right, so domain, which was left to right, it goes forever in both directions, negative infinity to infinity. And I'd have to put parentheses around those because brackets would imply it touches it, and you can't touch infinity. Range, the lowest it goes is 0. Does it ever touch 0? No.
It will never touch 0. And then does it get to infinity? Well, no, so I put infinity with a parentheses. There you go, there's no minor range. Okay, so you're getting the idea. I think you've mostly got what you need to know for today. So I want to review one of the hardest things from the other day. If I give you a starting value, 0, 4, and I give you some other point up here, and I say this is exponential growth, and I give you this value is, let me see on perspective, I think that looks like about 8, 8 to me. If I know it's exponential growth, you could always write a generic form, y equals a b to the x. But I told you a, and you can figure out b. Would you please rewrite this equation with, not when you figure out what a and b are, and the answer is not this, but something like that. Figure out a and figure out b. Okay, so if I wanted the start value, I would look here, because that is the y-intercept, which is where x is 0. If you think of this as time, it's like at time 0, and that's when you'd start. So then 4 goes here. And then how do you figure out the b? You put in the 8, 8 here and here. And so now I got 8 equals 4, b to the 8th, and then I'm a little worried about that 8th power, but I'll get to it in a minute. I'm dividing by 4, and then I get 2 equals b to the 8th, and then how do I solve that? I could do an 8th root, but that's going to look really weird. Would you agree that putting it to the power of 1/8 would get this to cancel that? So 2 to the 1/8 is my b. So I was trying to write it like this, and I was making up numbers for my starting value and my b. But here's my starting value for real. It was 4. And then my b is 2 to the 1/8. Isn't that interesting? A fraction up there in with the x. See what I did there? So to me, this says that this is going to double every 8, well, I haven't told you, but it'll double every 8 years or minutes or 8 seconds. You can write the problem any way you want. So in considering I didn't give you a context on this, it wasn't like how many llamas were breeding or whatever, so I don't know what the time should be, but I get to pick. The writer of the problem will pick. Okay, so I'll say it's days. So that's doubling every 8 days. And think about it, if it started at 4, it turned into 8, it was doubling, wasn't it? In how much time? X is the time. 8 days, it went from 4 to 8. It doubled in 8 days. Isn't that cool? All right. So, last thing I have to show you is if I give you this, and I think you're going to remember this from higher algebra, but I don't know. You should at least know that this is growth, and it started at 5. That makes sense so far. Then this is called the growth factor, and then the percent would be 20% growth. It's the part above 1. If I had just times this thing by 1, it wouldn't have grown at all. So timesing by 1 doesn't get any growth. But timesing by 1.2 gets you 20% growth. All right, so if I just asked you, here's a problem, 10, parentheses, 1.5 to the x, starting was how much? 10. Is it growth or decay? Growth. What percent growth? 50% growth. But this is important. Growth factor is different than percent growth. The growth factor would be 1.5. The percent growth, not 5. What is it? 50. And you put in a percent symbol. So on the Schoology quiz for today, which that's all there is for today is a Schoology quiz, and you'll probably even finish it before you walk out today. They're going to ask for the growth factor. It's just this whole thing. And the percent growth is that. All right. So let me give you one last example that's kind of tricky. It's only tricky because the numbers are huge. At some time in the past, in Minnetonka, we would have had like 45,000 people. Right now, if you look on the population sign for Minnetonka, you'll see it's grown to, and if you include, you know, like up to the minute kind of growth, probably around 60,000. But it did this, if we compared this, it might be in 1990, and that's not year zero, so that might be confusing to you. But it's still the starting number for our problem. Later on, the population goes up to 60, and it's not going to be as nice as 60. It's going to be like 61,108, some number like that. And this is going to be in the year 2020, which I know is a few years ago. Still the start value. Still growing. Clearly the number got bigger. But how would I actually write the equation for this? Always start with a b to the x. Everybody write that. And what's our starting number? Well, it's how many people were in Minnetonka back in 1990. 45,900. Don't put commas in equations, by the way. 45,900 is our start value. Is it growing? Yeah, but like, I don't know what percent that is. So here's what you do. If you took that number divided by that number, do you get it would be bigger than 1? It'd be like 1 point something. So that's exactly what you'd put here. 61,108 divided by 45,900. That's my growth factor. And then over how many years did it do it? 1990 to 2020. Over 30 then. That make sense to you? Start value. Some number that's bigger than 1, which came from this divided by this. And then it took 30 years. So we put that under it like that. All right, let's get started on your Schoology quiz. I think you'll find it to be not terribly hard. Number 1 on the Schoology quiz. Open that up. Got your iPad with you today? Excellent. All right, Riker, could you read me number 1?
So whether the function is exponential growth or exponential decay function.
Okay. What is the function?
P, T,
P of t?
yeah,
Okay, that means like y.
is equal to 3.5, parentheses,
Did you say 2.5 or 3.5?
3.5,
3.5.
and parentheses, 1.09 to the T.
All right. Now, I was kind of expecting it to say like over something. If it doesn't say that, then that means it's over 1. Think about that. Divided by 1's legal, isn't it? So this is growing by 9%, and it only takes 1 of our time unit, which might be years, might be seconds, might be minutes. Does it say if it's years, seconds, minutes? Okay, then they don't need to know that part. Okay, so question part A, what does it ask you?
Growth or decay, and it says
Just-
write growth or decay.
All right, write the word growth. Part B,
Growth or decay factor,
oh, what's that?
1.0.
1.09. Part C,
Constant percentage of growth or decay.
how am I supposed to write that? So I think it's 9%, what do I write?
It says, just write 9 and then the percent symbol.
You are correct. 9 is quite different than 9%. You gotta put the percent symbol in there. All right, are they gonna get more complicated? Of course they are, but I feel like that was a nice, easy one to start with. If you get stuck, I wanna help. Schoology quiz, that's all you gotta do between now and Monday. Sir,
If like the decimal's like 0.968.
you just write the whole thing out. So if this had been 1.0968, then I would have said that this is the factor, and then the percent would have been 9.68%. Unless they tell you where to round. If they don't tell you where to round, you always just move the decimal over 2 spots. So it would be like 9.68%. Makes sense. Unless they tell you to round to the 10th place, it would be like 9.7. Yes?
What if it's like 0.968?
Okay, so let's talk about what if this number gets weird, because that is going to be common. What if that number had been a 2? It doesn't even have a 1 point. Well, if it was a 2, I'd break it up into a 1, and then plus or minus, and if it's 2, it really must be 1 plus 1. Do you get that'll tell me that it was 100% growth, for example? All right, so then what if you have a smaller number than 1 here? What if it just says like 0.95? Well, then I'm gonna know that that's 1 minus 0.05. Do you get what I mean? If they give me a decimal, I'm gonna think of it as, well, then that's decay by 5%. I'm really glad you brought that up. I totally could see that happening. In fact, you probably looked ahead at a problem. Can you read us the problem you were looking ahead at?
F of x
Wait, which problem number?
2
Okay, number 2, f of x
equals 78,963 times 0.968 to the x.
Awesome. So right away in my head, I'm changing this to 1 minus something. So I can go, oh, this is decay. And then by what percent? Whatever goes right here, that would be the percent decay. So I know this is going to make you do math, but you got to figure out what will you subtract from 1 to get 0.968. I think it would be 0.032, I think. I wouldn't mind if you used a calculator and took 1 minus 0.968 and figure out what that is. Can anybody verify that that's the right answer? Okay, cool. So then, yay, I figured out my factor was this all along. That was easy. That's the factor. But the percent would be that. And then what is that? That is 3% decay. 3.2 to be exact. Now, I want to check for you to make sure that they didn't like round it. I think they're going to say 3.2%, but I'm going to check the answer for number 2 to make sure I'm doing it right. Edit. It is, in fact, 3.2%. And it was decay. All right. Thank you for asking. That was a very important point, and I had not talked about it, and I should, and I will in the next hour. So, question? Okay. All right. Now that's all I have for you for now.